It's really nice to see a Saturday morning with so many people discussing Postgres. This is something that interests me as well. The code is really good, used at so many places. The community is amazing. And I'm so excited to once again be here and sort of have some discussions with folks. The idea of this meetup is more about community than the exact technical knowledge that the speakers will present. Having said that, we have three amazing talks. Let's start with the first talk. I'll very quickly introduce the first speaker. Please give a big round of applause for Senthilnathan from the Cloud SQL team at Google. How many of you have used Cloud SQL or heard of it? Just tried things around. Obviously, Vasudev is there. Your hands don't count because you are one of the builders, as is Senthilnathan. So Senthilnathan, in his work at Google, focuses on Postgres performance relating to Cloud SQL. Cloud SQL, by the way, is fully managed and a cost-effective one to have managed Postgres instances to build your app. And Senthil has a deep experience in databases, distributed systems, and stuff. Worked at Intel, VMware, Amazon, and now at Google. So quite an illustrious career, and has managed hundreds of Postgres clusters in his past role at VMware. Today he will be talking about Postgres 18 features. I remember the first meetup we ever did here. We had Amit talking about Postgres 16 and 17. Now we have this talk. It's amazing that we can get a sneak early peek into Postgres 18, some of the features. Of course, it's not possible to put all the features together and explain it in the time-bound manner, but I think Senthil's approach is something that I really loved. I saw his slides and he has few features, but he's explained them really well. What was the problem, description of the issue, and what they've done with Postgres to fix it or make it better with Postgres. So let's just hand over to Senthilnathan without much ado.
Yeah, thank you. Thank you. I hope I'm audible for all of you. Yeah. So Postgres 18, the release process, right? So Postgres is one of those very rare projects which makes releases every year, every major release every year, and on a schedule with a lot of major features, including especially considering that open source project. That's something which is really interesting. So for 18 release, the code freeze happened on 8th April. So this month. So after this, it'll only going to be bug fixes and documentation, right? So it's a good time to just see what are the features which are there in Postgres 18, right? And number of commit phase has happened during this period, last 1 year, and several hundreds of commits. And many of the audience here are PG hackers who have contributed. So that's a scale. Just a small poll, we can, if you can answer, it will be interesting to understand the community and the audience here. If we can switch to the link at the top. You can, if you're primarily a backend developer or somebody who is working at the SQL layer, you can, choose application developer. If you are somebody who is primarily somebody who is managing the Postgres clusters, you can choose DBA DB, or if you're contributing, you can choose PG Hacker and other. I think this doesn't have the QR code, I think. Yeah. Can we go back to the other one? Yeah. I think the QR code, yeah, in case somebody wants to scan. Yeah. I think we can go back. Very positive. Okay. Yeah. So it's the application developers who are, the leading here, followed by someone, people who are managing the Postgres database, and then PG hackers. So interesting. So yeah, we can go with. Thank you. So the thing I wanted to kind of highlight is that this Postgres release has something for each of these group. So for developers, DBAs, and so on, right? So obviously, it's impossible to cover all the features committed so far in this small talk. So what we are going to do is cover only a subset of features, something which is of interest to the community, which people liked it, gave real good feedback. Those are the features we are going to talk. So definitely going to be a small subset. And also there is a small possibility of these features being reverted if there is any major bug found before the actual release. So that's also something to keep in mind. So these are the three aspects I've kind of looked at, and from this angle, what are the features, right? So one is for developer productivity, from a backend developer, application developer perspective, and then the DBA productivity. The third one is performance, and since I work mostly on performance-related aspects, this is something of interest for me. Okay. Yeah. So first feature we will look at, right? Generally when there is a query which is very slow, right? The first thing we look at, explain, analyze, right? And if you look at general database system, right? Most of the performance issues are to do with I/O, right? Very rarely it's on the CPU side, and that is true for OLTP workloads generally. And dealing with too many data pages is the most common reason for poor performance, right? So explain, analyze is the first point we start with. We run it, we look at it, how the query is behaving, right? So there is one option there called buffers. We can provide this flag. It just helps us to see how much I/O work Postgres did, when executing each node of the query execution plan, right? And making this as the default behavior. There's been a lot of requests for this, from the community. So, for example, this blog post, this was, as you can see, this was written in like 2022, almost 3 years back, and they are just talking about the importance of this buffers flag when you analyze any query, right? So this is the blog post from Nikolai, who is like founder of Postgres AI. So he also runs this YouTube channels called Postgres TV and a podcast called Postgres FM, which is very good. I highly recommend that. So these examples are from the same blog. So let's consider a simple example. Two tables, each has just two columns, right? One is ID and the other one is num. Num is going to be random data with exactly the same content. The second table has the index, while the first one doesn't have it, right? So table T1, we create with random numbers of 100,000 range and 1 million entries. We copy over the same table to T2, and then the ID is the primary key, and we create the index in num using B-tree. We do vacuum analyze in both the tables just to keep the stats updated. You can guess what the behavior is going to be, right? So we are going to query the database just to get 1,000 rows from this table with some condition. Num is greater than 10,000 and we want to order by num, right? Simple query. Let's compare the plans for both the tables, right? I put just side by side, right? So this is the explain, analyze output. There are too much of data there, but the important thing to note is that the first one is using the sequential scan, right? The second one is using the index scan. As expected, no surprises there. The first one, you can see the execution time at the bottom, around 300 millisecond. And the second one, the execution time is around 2 millisecond, right? Now, this gives us a very high level view of things. And most of the time, in practice, things are not as simple as this, right? So let's just look at the next level detail here. So if we just pass this buffers flag on the top of the line, we can see that we are saying explain, analyze, and buffers, right? Same query. We can see that the buffers is listed for each node, right? We can again compare between the two queries. The first query, the buffers is around 54,000, right? That is the actual number of buffers read to answer this query. The second one, you can see the buffers is just 1,000, right? So the amount of data which needs to be read to answer this query, that largely determines the performance of the query. So, 54K buffers, each buffer, we know it's 8 KB. And so if you compute it, it's 400 MB of data. Quite a lot of data to read just to answer, in a 2-column table, 1,000 rows, right? For T2, we have 1,000 hits, which is something like 7.8 MB. You can just compare, the amount of data and the difference. And so that is, that gives us a lot of insights, right? The final goal of any query optimization that we want to do is actually to reduce the time. That's the goal. But what we really want to look at is this, the reducing the data volume. That's the kind of the objective. If we achieve that, the timing automatically, follows, right? So the feature in Postgres 18 is that this option is enabled by default. Of course, if you want to, disable for some reason, there is a way to disable that as well. Yeah, let's move on to the other one. So UUID V7 support, right? Just a refresher on UUID. They are 128-bit values which are, designed to be unique without, need to have a central authority to manage them. So especially if you have a distributed system, right, where and you want your keys to be unique, UUID is a good option, right? So it makes them ideal for primary keys because they are unique. So naturally, it's good. And already Postgres supports UUID v4, right? One interesting property of UUIDs is they are not sequential, right? So they are randomly generated UUIDs, right? It's great for some use cases because as a backend developer, you don't want people guessing what is going to be the next entry, right? If you increment my primary key, will I be able to access others' data? So all those concerns, UID is great because it's random. It's very difficult to guess. That's why people choose primarily UID. But from a database performance perspective, this is a very bad choice because it's random. It's going to give very, very suboptimal performance because the data being accessed, or inserted, is going to have a bad temporal locality. That means we need to read a lot of pages randomly. If you follow the index tree, you will have probably for every node, we will have to read a new page, or there is no good reuse of data within the single page that we have already read. So that's the problem with UUID v4, right? So Postgres 18 supports UUID v7 just to improve this randomness, right? v7 encodes a unique timestamp with some millisecond precision, and so it's time-based, and hence there is some ordering which is maintained, right? It's not random. So this eliminates the drawback of poor temporal locality. And since the timestamp is also encoded as part of UUID, we don't mean to maintain, created at columns separately, right? Most of the entries you'll see created at. Now you can just use the same UUID to get the timestamp when it's created. And Postgres also provides a nice method to extract the timestamp, right? So again, this is another performance analysis done by community last year by Jeremy Snyder. So seconds to insert 1 million rows, right? If you use UID as a text or V4, V7 and begin, right? Just inserting million rows, you can see the huge savings in terms of time, right? And this gives another view why UID v7 is better, okay? So if you look at this graph, which is basically the wait events, right? If you focus on the blue color one, between V4 and V7, right? I don't know if it's visible. The blue color is basically the data which is fetched, amount of data which is fetched, right? So you can see the V4 needs to bring in a lot more data because we're randomly going and fetching a lot of pages. So that's a lot more data. V7, a lot of data is there in those buffers which are already read. So that's why we need to read less data, and then the performance is better, right? This is another view of the same thing. If you look at the buffer usage, right? That means once the buffer is in memory, a page is in memory, how many times we are reusing the data, right? You can see that for UV4, the green is quite large, which means that it's just one. Green corresponds to one. So each page is just read like single time. It's not reused at all. Whereas for V7, you can see the top yellow bars and all are very high. That means there's a lot of reuse. So it's a different view. Okay, we'll move on to the next feature. This GIN indexes, right? So they are suitable for data types that are slightly complex and which are dividable, like array elements, or you are storing a full text and then you want to search by particular word, keys in JSON-B, and so on. It's called inverted because there is, the single row of the data, single tuple, can be, pointed from multiple places. You can think of it like a text, and then each of the word will have a pointer to the text, right? And it's very similar to the index in a book, right? In fact, that's where the name index is originally coming from, right? So back of the book, each probably, each word, where is the page it belongs to, right? So there'll be multiple references to the same page. So as you can imagine, it's going to be more expensive than B-tree and hence slow to be created, right? That's expected. So this analysis was done by Deepes, who I'm sure it's all familiar for you. He maintains a page for explain, analyze. If you paste it, it gives you a nice breakdown of what explain, analyze, and so on. It's the same author, right? So we are just loading 1 million random arrays, where each array has 50 to 150 elements, right? And the elements are within this range, right? So it's an array search that we are going to do. So we are creating a table and load the data to the table, and we create an array with a single worker first, right? So we disable this max parallel worker, and then we created an array. It's you can see it's the amount of time it's taken is around like 77 second, right? If we just look at the explain, analyze for this, right? This is how that gets actually executed. If you move to the parallel index, right? So we just make it as 10 workers, right? And then create the index. So it's like 53 seconds, like almost 30% reduction in terms of index build time for gene index. So this is another improvement in Postgres 18. So this is probably interesting from a admin point of view, right? One of the most common problems when we do PG upgrade, right, is that database is slow after the upgrade, right? A common pattern. We need to run analyze to refresh the statistics, right? So the planner is, as we all know, it uses all these statistics that built over a time to, come up with the better plan, right? But when the upgrade happens, the statistics is lost. We lose the statistics. So after the upgrade, we are starting, from scratch in that sense. So the planner doesn't have any clue how best I can, plan my query. That's the challenge, right? So in PG18, this PG upgrade automatically supports transferring statistics, for the upgraded version, right? So internally, it's using this PG dump to just dump the statistics and then restore. But I feel this is a very good feature. Okay, this is something which is Postgres already has support for generating columns when you are inserting a data, right? Let's say we have few columns in a table and then one more column, that it's always sort of generated with some formula, right? So you can mention that to be generated so that at the time of writing. But this feature is something which is helps us to generate this column while reading, right? So for example, let's take this. You have ID and primary key, and then another column called n. So we are inserting this data, some random data from this series. And so this is how the table looks like now, right? Now, size of the table is around 729K. We are introducing another column which is generated, right? It's virtual because it's not actually being stored in the database, right? You can see that even after introducing this column, its size is same, right? It's virtual column, right? So when we query, we can see that it returns that column as well, right? So at the time of reading, it kind of generates it for you. So obviously there is going to be some, performance impact while reading. And it's a toy example here, but I can imagine a lot of interesting use cases for, this feature. Okay. Quickly about backend statistics, right? Till PG17, at the server level or the database level, we have a lot of interesting statistics with respect to reads, writes, IO pattern, and so on, right? But this one is more targeted towards a single connection or a single backend, right? This is something interesting. So, for example, right, I am interested in to know, I have this application which is, running these queries. What is the IO pattern for just my application, not the whole cluster or the engine, right? So you can say, you can run this query by using the backend PID, which is the PID for current backend. And then we can just get all the statistics, IO statistics. There's a lot more. I have just listed only very few. And so this is only the just a number of pages and things like that. There is also, support if you want to, if you are an admin, a database, managing a database, then you can probably kind of try to understand, which backend is generating, let's say the most number of hits or the most number of reads, right? It's possible to query now because we have per backend level statistics. It's possible to, get these data. Yeah, what is the writes generated by each of the application, and including, if you the percentage writes for the whole database server, right? This also allows us to get val related data, not just the data pages. So that also we can get it with some, enabling this track val IO timing. We can get the IO timings for val objects as well. So for example, for my current backend, how much of val is getting generated, right? So and then we add this where object equal to val, and we get that. Find the top 3 backends that are generating the most val bytes. I'm sure this is kind of interesting for someone who is managing the database. Okay, and once the backend is disconnected, these stats are not available. They are available only as long as the connection is there. Okay. There are other major features. Changing of auto vacuum max workers, right? Most of the time when vacuum is not happening at the speed that we expect, right? It can have very bad consequences, we all know. So the first thing, one of the things we want to tune or increase is this variable flag, max workers. But the problem is, till PG17, this requires restarting of the instance, which is in general not acceptable, right? So PG18 allows us to increase this without restarting the server, right? Asynchronous IO, this is a major topic by itself. It requires a separate talk, I would say, just going through the details. But at a high level, what's happening is the CPU does not block while the IO requests are happening. So at a high level, so obviously that's going to give a much higher performance. And so this has been in works for last many years. and PG18 has some support for it. Right. Okay, that's all I had. Yeah, thank you. Any questions?
Just raise your hand if you have a question, and I'll get the speaker to you.
While you were telling about the first feature about explaining or the analyzing about the, like, we can analyze the buffer size and
Sorry, voice is not
Yeah.
clearly. Can you
yeah.
speak
Now
a
I'm
little?
audible, I guess. Am I
There's
audible now?
some echo there. You can.
Yeah. So I just wanted to ask the difference between, like, are we using currently buffer scan or index scan? And while, because in the slide itself, both the queries were same, but one was using buffer scan and another
Right.
was using index scan.
Right.
And there was a quite difference between the performance of the two.
Right.
So, like, is it like the SQL decides which scan it will be using, or what we provide actually?
Oh, I see. That's decided. I think you are asking what decides which scan is being
Scan is
used,
being
correct?
used.
Right. That's decided by the planner, right? Based on the statistics it has built and what it thinks will be the best performance, right? That's internally decided by the planner. Most of the time it's accurate, but there are cases where it can fail. Yeah.
Yeah, and one more thing, like, when you were telling about the PG, like Postgres upgrades, so you tell, right, that the Postgres database gets slow a bit, right?
Could you repeat? Sorry.
Yeah, so while talking about the Postgres upgrades, you told about that it becomes a bit slow, right?
Right.
Does it only because of the stats only, or some other reason as well, like?
Okay. I mean, of course, the data, everything is there. This was like the only major missing piece which affects the performance after the upgrade. So this is sort of supported now in PG18.
Yeah, thanks.
Thank you. Yeah.
Any other questions? Yeah.
Yeah. Hey, so my question was, what's the vacuum state you were talking about?
Sorry?
What's the vacuum thing?
Vacuum, right? I think the next talk is Neeraj will be covering that. MVCC and vacuum related things. I'm sure it'll.
Thank you.
Yeah, Vasu, I think. Yeah.
Any questions here? Anybody wishes to ask?
Hey, Senthil, thank you. Great talk.
Yeah.
Quick question about the V4 to V7 upgrade.
Yeah.
Will that break compatibility when there's a major version upgrade happening?
Could you talk a little louder, please?
Okay. Is this better?
Yeah.
Awesome. First of all, yeah, thank you. Great
Sure.
presentation.
Yeah.
Quick question about the upgrade from 17 to 18.
Right.
Will the UID 4 to UID 7 be a major journey over there, or will that break compatibility?
I see. For the developers themselves, right?
For the developers, for the person managing the databases.
Yeah. I haven't thought about that. Probably for people who are starting to use, fresh for V7, definitely the performance. I don't know what is the compatibility story between V4 and V7. I'm guessing there would be, because since it's a standard. But yeah, I'm not sure.
Thank you, Senthil.
Yeah.
And once again, great presentation.
Thank you.
More questions? Yeah.
Yeah, hi. One question about virtually generated columns.
Right.
So basic question, like I will go to read more about it, but you mentioned it has some interesting use cases.
Right.
Like it's very new for me. So can you tell some use cases for this?
Right. Right. So cases where, let's say, field is always generated using some formula, for example, right? I feel that those are the cases. Instead of probably doing it at the application level, right? If the formula remains the same, it's possible to sort of offload this to the database, right? So that's the use case I can think of. I hope, yeah, there may be better cases, but yeah, this is what I'm thinking. Yeah.
Hi, audible?
Yeah.
Yeah. So is there any risk in migrating from V4 to V7?
Right.
Since we're like removing randomness at the start of the UUID to like some structured field at start. So is there any like risk in getting duplicate keys?
Okay. If we are upgrading from V4 to V7, right? Is there any possibility of getting the duplicate key?
Yeah.
Right. I think that's a good question. So if you look at the standard for V7, in UUID in general, right? Even when that gets generated concurrently across distributed system, is a very less possibility of getting a duplicate, right? That's why it's called universally unique, right? So in that, it uses timestamp, it uses the MAC ID of the engine and so on. So very unlikely that we will have duplicate primary. Yeah.
Got it. So, like, are we just getting some benefits over the index that we create, or is there anything else while we are migrating to V7? So, like, since it would be somewhat sorted, so the
Right.
B tree that it's created would be like faster to traverse.
Right.
So,
Yes.
it's just the index, or it's anything else?
I didn't get the question. Sorry.
It's just the index that we're getting benefit, or like, is there anything else?
Okay. You're asking whether the index performance is better. Is that the main advantage?
Yes.
Okay. Yes. Yeah, that's the advantage. Just the amount of data that you have to read, right? UUID v4 is it's a bad choice for databases purely because of this reason. Yeah. Thank you.
We still have a few minutes. So yeah, more questions.
Yeah. Hi.
Yeah, bit louder.
Can you hear me properly?
Yeah.
So I just wanted to have my understanding correct about the asynchronous I/O of the CPU.
Right.
So basically, like whenever you get a query, you basically look at the files and then you read the files and then you do the processing and all
Right.
that stuff.
Right.
I mean, isn't that the case? Like whenever you read the I/O buffers, like you do it asynchronously, right? Like what's exactly changed there?
Oh, okay. Little louder.
Sorry. I mean, whenever you're reading I/O buffers, like you do it asynchronously, right? Like that's
Right.
the default. Like
Right.
that's what people usually do.
Right.
What exactly changed in the upgrade of that asynchronous I/O?
Asynchronous, right?
Yeah.
So Postgres is kind of very unique in terms of the storage architecture, right? Most of the other database engines, if you look at it, they use direct I/O. It means the request goes from, let's say, memory to disk, right? Postgres has something called OS cache, operating system cache, which is in between layer, right? So from memory, you go to OS cache and then you go to the disk, right? So already there is one level of, extra hop is there. But from OS cache, let's say we are bringing in a page, right? Right now, that is actually blocking the CPU. The CPU is blocked on, it's a copying over to the memory. That is the blocking synchronous.
One small question.
Hmm.
Like, is the in-memory and OS cache the same thing, or like, do you mean the off-heap memory of the OS cache? Like,
Please repeat.
sorry. I mean, when you said in-memory and OS cache, like,
Right.
aren't they both the same thing? Like,
If your whole data is in memory, you are asking?
yeah, I mean, when you mean OS cache, like, are you referring to some file stored on the disk or
Yes.
in the memory RAM?
It is in memory. It's
Okay.
memory, but used as OS cache. Okay.
Okay.
For example, Postgres has this shared buffer memory area, right?
Okay.
Typically, if you look at the documentation, it's recommended 30% or 25% to reserve for that, right? Remaining 75% is used as the OS cache. It's memory,
Okay.
but it's managed by the operating system, not by Postgres. Okay.
Okay.
And there is some copying happening. That's where whether it's blocking or it can do asynchronously. CPU is freed. Once the copy is complete, it can just call and interrupt to the CPU saying, hey, I'm done. So that's how the performance benefit is there.
Okay, I mean, wasn't that the case like with every database like?
Yeah, probably we can talk offline.
Oh,
There's a
sure.
great talk by Andres, who is the one who authored this commit. I can probably share it with you.
Yeah, sure. Thanks.
More questions? I don't see any hands yet. Okay.
Hello, audible, sir?
Yeah, yes.
Thanks for the talk, first of all. How does the AI usage change how DBAs or experienced people like you are solving DB problems?
Okay.
Maybe in the scale of how Google, the SQL cloud which it provides, how do you guys solve problems now? Because now you can ask AI to tell what is the probable solution for this context, etc. And then it probably gives out much better answer than what a normal DBA would know. So how is it changing at Google or if
Right. I think for whole PG ecosystem, that's a great change happening. I think extensions like PG vector, right, are becoming more popular. And I think last time we had a talk on PG vector support in Postgres. So Postgres being very extensible is really helping to onboard a lot of these vector workloads. Rajiv from our team, LIDB team, he works specifically on vectors. Probably you can talk to him and he'll share more.
Thanks.
Yeah.
Okay, one last question. We are well into the break. So any other questions? Okay. Okay, pretty much on time. Yeah, thank you. Thank you so much, Senthilnathan.
Thank you.
Great talk, and the amount of engagement shows a lot of insights. What I loved is you managed to put a blog or extension to read more on a breadth level talk. That's so nice. We have a small token of appreciation for you from our side. Thank you.